All right, guys, welcome back to our video here for the 2024 Regents exam that happened in June. So far we've gotten through 18 multiple choice questions. Let's see if we can finish those up and get through these part twos as well. So the next multiple choice question asks us about an inverse. Once we get the word inverse, we should think switching or swapping the x and y. D of x is kind of like where the y is. So if we switch the x and the y to make the algebra solvable, we don't want to put function notation in there, we get this expression. Notice it's not a choice because I need to solve for y. Well, to solve for y, I would cube both sides. So we'd wind up getting x cubed is equal to y plus 2. We then can quickly just subtract the 2 to the other side. And we get our inverse, which is x cubed plus 2 equals y, or d to the negative 1 of x, either 1. And we wind up circling choice 4 and moving on. Since this is multiple choice, you could have also tried to do this using the calculator. You could have graphed the original and all your choices and looked to see which one was a reflection over the line y equals x. Number 20 is kind of a tough question. So it wants us to essentially figure out all of the potential zeros of the function. It gives us some zeros that are real, some that have some i's in it, some complex zeros. And it tells us one of the zeros already. So it tells us f of 3 is 0. So x equals 3 is definitely an answer. So it can't be choice 2 and it can't be choice 4. Those don't have positive 3 as a solution here. Now from here, the algebra is going to say, well, if we know 3 is a 0, that means we know x minus 3 is a factor. To find the other factors, I have to factor out x minus 3. Essentially, I need to divide out x minus 3 because this has 5 terms. This is not factorable using any of the methods we learned in Algebra 2. So if we start doing our division, we'll division practice here as well. So we're trying to create the expression x to the 4th, x to the 3rd, negative 3x squared, and 9x. And since it's a factor, this last box should be negative 108. If not, we made a boo-boo someplace. So in the division, we're asking ourselves lots of questions. Remember, when you're dividing polynomials, you're just constantly talking to yourself. So we're saying, what could I multiply x by to make x to the 4th? That would be x to the 3rd, which then I would multiply and I'd get negative 3x to the 3rd. Well, to make that add up to positive 1x to the 3rd, I would need to make this positive 4x to the 3rd. Well, then I have to ask myself a question again. What do I multiply x by to make 4x to the 3rd? It would be 4x squared, which would make this negative 12x squared. Well, I need to add up to negative 3, so then I have to say, what do I add to negative 12 to make negative 3? Well, that would be positive 9x squared, which would make this 9x, which would make this negative 27x. But I don't want negative 27x. I want positive 9x. So we have to add 36x to that, which would make this 36 and this 108, negative 108. So that checks out that it's definitely a factor. And now I know where the other factors lie. So here's what we know so far about f of x. So we know f of x has a factor of x minus 3. And the other factor, this cubic factor, is x cubed plus 4x squared plus 9x plus 36. To find the remaining factors, I need to factor this cubic expression. So since it has 1, 2, 3, 4 terms, we're thinking grouping. Notice grouping has happened now twice on this test. It's one of those factoring methods they love putting on this exam. So we can take out x squared from those first 2 terms, take out 9 from the last 2 terms, and then we can combine that common factor by factoring it out. So we can say we have factors now of f of x minus 3, x plus 4, and x squared plus 9. And then Because I'm trying to find all of the factors, including the non-real ones, I need to try and factor this expression, which can't be done with difference of two squares without having to use imaginary numbers. So in class, I probably would have written it like this, so that we can think it's still difference of two squares, and I'm saying, what's the square root of x squared, and the square root of negative 9, which is 3i. So then we can factor this completely over the complex numbers by saying that last expression becomes x plus 3i and x minus 3i. Now we'll use that zero product property to set all of these factors equal to 0 to get answers of 3, negative 4, negative 3i, and positive 3i. So plus and minus 3i is going to come from those last two non-real factors. And we wind up getting our answer, which is going to be choice 3. If you had graphed it, you would have only seen the negative 4 and 3 as solutions as x-intercepts. But since it's quadratic, you know there's 4 total solutions, so you might have actually been able to answer this question without doing any of the math, just knowing how factors work. The next one gives us an explanation of the profit function. So it says the profit function can be found by subtracting cost minus revenue, cost from revenue. So we can say the profit function P of x is equal to the revenue function minus the cost function. Remember, subtracted from means it's opposite order. And they want us to determine the cost function. So we can input the functions we're given right now and try and solve. Or I can solve for C of x using this notation and then plug in my stuff. So I'm going to subtract r of x to the other side. So I have P of x minus r of x equals negative C of x. I don't want negative C of x, I want positive C of x, so I'll divide everything by negative 1. I am just doing algebra with functions here now. So we're going to have negative P of x plus r of x equals C of x. I don't like the way that looks, so I'm going to rewrite it as C of x equals r of x minus P of x, right? We'll just swoopy swap those. Now I have what I'm looking for as what's equal, so whatever I get from my algebra here works. So if we plug in the r of x function, the r of x function is negative 0.4x squared plus 130x plus 1200. I want to put in the negative of P of x, because I would have to distribute the whole negative to this entire P of x expression. So negative P of x would be a positive 15x squared, change the sign, a negative 600x, change the sign, and a negative 60, and now I just have to combine up some like terms. So if I combined up some like terms, 15 and negative 0.4 is going to be 14.6x squared. 130 and negative 60 is going to be negative 470x. And 1200 minus 60 is going to be 1140. There's my C of x function. I just have to find it in my choices. There it is, choice 3. I move on. Number 22 is asking us to divide two polynomials, but it's only asking us for the remainder. So yes, we could do the division. However, if we just know the remainder theorem, this is a relatively easy question. So if x minus 2 is what I'm being divided by, I want to plug in 2, because that's what would make that expression 0, so that I can see what the other expression's value is when 2 is plugged in. That's the remainder. So we'll say 4 times 2 to the third minus 3 times 2 plus 3. I can then just type that into my calculator, and I can get 29. That's how the remainder theorem can help you. If you don't want to show all that work, you could actually graph this cubic polynomial and just see where x equals 2, what the value is. It will be 29, and you're good to go. That should be easy peasy. Number 23 gives us a parabola, and then it asks us about the vertex, the focus, the directrix, something like that. So whenever we think focus and directrix, we want our equation in this form, where h comma k is the vertex, And P is the distance from the vertex to the focus and the direction. So if P is negative, it's below. If P is positive, it's above. So first thing we have to do is we have to manipulate the algebra here to get this equal to y. So I'm going to divide by 12. So I have y plus 1 is equal to 1/12 x minus 4 squared. If you remember in class, we said dividing by 12 is the same thing as multiplying by 1/12, so we can make it look like what we want. We then can subtract the 1 to the other side, and now we have our equation, which is 1/12 x minus 4 squared minus 1. From this equation in vertex form, we should be able to at least sketch what this parabola looks like. This first fraction is positive, so that means we know it's a parabola that's going to be concave up, it's going to open up. Because the vertex is going to come from this expression x minus 4 minus 1, we know the vertex is positive 4, negative 1. Notice the h is positive here, but negative in vertex form, so it's opposite. And then if we look at the 12, well, what do we multiply 4 by to make 12? That would be 3. So if I count up 1, 2, 3, this is now my focus. So my focus is at the coordinate 4, 2. Think about counting up 3 from negative 1. That is my focus. If I count down 3 boxes, I'm going to be at the directrix, which is a line. It's horizontal. Since it's horizontal, it's a y equals equation. And it would be 3 units down from the y value of negative 1, which would be negative 4. So now we know the vertex, we know the focus, we know the directrix, we can look at our choices. The vertex is not 4, 2. The focus is not 4, negative 1. The directrix is y equals negative 4, so I'm not even going to look at choice 4. Number 24 is asking us about a bike race taking over 15 weeks. We're increasing the ride by 9% every week. This sounds like a sequence question, but it's not, because we want to know how many total miles. This word right away is telling us this is a series. It's a geometric series because we have a percent or a multiplier. So we know that the first value, a sub 1, is going to be 10 miles. We know the ratio is going to be 1.09 because that's what I multiplied each term by to make the next. So if we find the series value for these 15 weeks, we can use the geometric series formula that is on our reference table. So on the reference table, it says to take the first term minus the first term times the rate, all to the number of weeks, all divided by 1 minus that common ratio. Again, I'm just inputting into a formula. We need to know to use the formula because it says total, so I want to add up all of the numbers here. This formula is going to do that for me. Now, if we're taking the Regents exam and we forget how to use the geometric series formula, we could find every single week's number by multiplying 10 times 1.09, finding week 2, then multiplying another 1.09, finding week 3, and find all 15 weeks and add the 15 numbers together. It's going to take a lot of time, but you have it. You have 3 hours to take this test, and we wind up getting this number when we type it in the calculator. So there is your choice. From these videos, I'm hoping that you're picking up a couple things. First off, multiple choice questions can be answered using your calculator. Whenever possible, check on your calculator so that you're making sure that you got the right answer. The answer is right in front of you, so make sure you're looking for it somewhere else other than whatever your work is. So let's move on to some free response questions. So in part 2, these are usually 1 or 2 step problems. They shouldn't require a ton of work. So we want to be careful we're not giving away points, checking rounding, making sure we're in the right notation, all of that fun stuff. So let's jump here into number 25. So the first thing I notice is I'm multiplying 2 expressions together. I know they have I in it, but I'm going to multiply it the same way I would multiply any 2 expressions. I'm going to make some boxes. I'm going to put one expression on top, the other one on the side. And I'm going to carefully multiply. 3 times x is 3x. X times negative 2xi is going to be negative 2x squared I. 2i times 3 is just 6i. And 2i times negative 2xi is going to be a negative 4. 2 times 2 is 4. X has nothing to multiply with. And I times I is I squared. Now we hope to remember that I squared is -1. That is the 1 power of I you should just know right off the top of your head without having to do much work. So since we know I squared is -1, I can actually rewrite this as -4x times -1. That does not look like -1, that does, which is equal to +4x. Which when I rewrite this product, I'm going to get 3x, I'm going to get -2x squared I, I'm going to get +6i, and I'm going to get +4x. And then we can't forget about this +2xi, which is going to come down, +2x squared I. Now it just becomes, can I combine like terms and put this in the right form? So we can see the +2x squared I and -2x squared I are going to eliminate each other. They're going to become 0. 3x and 4x becomes 7x. That's going to kind of act like my real part, the a in a plus bi form. And I will put 6i at the end since we want it to be in that right form. So say, for example, you wrote 6i plus 7x. It's not that you're wrong. You wrote it in the wrong form. You're not getting both points for this 2-point question. So you got to be careful. Number 26 asks us to algebraically solve. You can absolutely graph this and solve it using your calculator, but it does say algebraically, so you're not getting points unless you do some kind of algebra here. If you want to get the answer on your calculator and put it on your paper so that at least you get a point for the right answer, that works. But let's do the algebra. So since it has an exponent that has a variable, we know we're going to need logs here. Since the base is e, I'm going to assume I'm going to use natural logs. So I'm going to divide by 3.8 to the other side. E to the 1.5t is equal to 16 over 3.8. I don't care what 16 over 3.8 is. I'm just going to leave it. The calculator will eventually do all the work for me. So if you remember, when we have exponents, if we have an exponent has a base, as an exponent is always equal to an answer, well, that can use logs to solve for the exponent by saying log of base b of whatever that answer is. Now, when the base is e, so we have e to an exponent equals an answer, we can say, well, that exponent is equal to just the natural log of the answer because logs with base e are natural logs. So I can rewrite this as the exponent, 1.5t, is equal to the natural log of 16 over 3.8. From here, we're just going to divide by 1.5. We'll just divide by 1.5, and now it just becomes typing it in the calculator. So if we take the calculator here, Desmos, where are you? There we go. So if we type that into our calculator, so we have our natural logarithm is going to be underneath functions, or you could just type in ln. Right, so we have the natural logarithm of 16 divided by 3.8, and that parenthesis, and then divide that number by 1.5. And we get our answer. It says to round to nearest hundredth, so that would be 0.96. Number 27. In an attempt to get the student's body's opinion on a new dress code, members of the stats class surveyed students in the first period computer science class. Explain the statistical bias in the method of data collection. They only asked people that are in computer science, meaning this is not a representative sample of the population. Are samples not really being taken randomly? Could also be an answer there, right? They just went up to a period class and asked everybody. They didn't randomly select what class to take. But the fact that it's not representative of the population is the bigger issue here. They only asked computer science students. They didn't randomly choose computer science class. They just picked that class. So that's an issue. We can say it's not randomly selected. That's an issue. We're only taking people that are in computer science, and all of the other people that aren't in computer science weren't even potentially in the survey or the sample. So not being a representative sample or not being randomly selected are two answers to 27. Number 28 asks us to sketch a polynomial. Notice it tells us that the polynomial has 3 zeros that are only at those numbers. So those are our 3 zeros. But it tells us that the end behavior is pointing down, down. Well, that tells us that it's going to have an even degree, which means there has to be 4 zeros. That tells us one of these 3 zeros has to be happening more than once or twice. So one of these has to have a multiplicity of 2. It's pretty wide open and vague. It could be any of them. So what they're looking for you to do for this question is to label those 3 zeros at -5, make it look somewhat good, +1, and +4. The graph's going to start down here, and then it either can bounce or be tangent to the x-axis at -5, 1, or 4, your choice. So I'm going to make it pass through -5. I'm going to make it pass through 1 and bounce off of 4 or be tangent at 4 so that I'm ending with end behaviors of down, down. You could have made it bounce off of 5. You could have even tried to make it bounce off of 1, although I don't think you can. But as long as your end behavior is right and you're only passing through the x-axis at those 3 locations, your graph is good. I would also always try and label your graph. Use arrows and we're good to go. The next question gives us a Ferris wheel problem. It gives us a sinusoidal function, and it wants us to determine the period and explain what the period means. So the period is going to be whatever is multiplied to your variable as the frequency. So our frequency is 2 pi over 5. To find the period, again, that same relationship that was in that one multiple choice question. So the period times the frequency is always 2 pi. So if we plug in the frequency, we can find the period. So we have this expression that we are trying to solve. We can multiply both sides by the reciprocal because that's what we do when we want to try and get rid of fractions algebraically. And we can see that these 2 pi's are going to eliminate themselves, giving us a period of 5. Now, in the context of this problem, the variable is in terms of minutes. So that's going to mean it's going to take 5 minutes for the wheel, the Ferris wheel, to complete 1 full rotation. Notice I'm trying to use a little bit of context in my answer as well. Number 30. Number 30, we need to create a common denominator. Our common denominator here is going to be x times x plus 5. Whenever our denominators have variables in it, if they're not factorable, just multiply them together. That's your common denominator. So I'm trying to create 3 different common denominators, right? So we're going to make every fraction have that common denominator. And now we're going to think what changed. So from x plus 5 to x times x plus 5, I would have had to put an x here. So I got to put an x here. So I'm going to put 8x on top. From x to x times x plus 5, I need to multiply x plus 5. So I'm going to put 3x plus 5 up top. To go from 1 to x times x plus 5, I got to multiply both of those. So I'm going to 5, an x, and an x plus 5. All of this in the numerator, now that the denominators are all the same, becomes our equation. Essentially, we can cross these all off and say those don't matter anymore. They're all the same. So I have the equation 8x minus 3x minus 15. Remember, you're going to distribute this whole thing. Equals 5x squared plus 25x. And hey, look, again, we see x squared somewhere in an equation. We want to make this equal to 0. So let's do that. So we want to move this all over to the other side. So we have 5x minus 15. Let's simplify first, clean it up. We can move the 5x and the 15 to the other side. So minus 5x and plus 15. So we have 0 is equal to 5x squared plus 20x plus 15. I see that there's a common denominator of 5, so I'm going to divide it out to make my life easier. So I wind up having 0 equals x squared plus 4x plus 3. From here, it's just, can you factor? What multiplies to make 3, what adds to make 4 is 3 and 1, though it's all equal to 0. So my two answers are a -3 and a -1. To check, you can graph it and see where the two sides of the equation are equivalent. Or you could just look back and say, well, either of these two numbers make any fraction in this problem undefined. They won't. So both of these are our answer. You could show them separate, or if you want to be fancy pants, you can make a solution set. Number 31 is an independence test. I guarantee you, you will have an independence test somewhere on your Algebra 2 Regents exam. First thing we want to do when we see a two-way table is create the totals if they aren't there. So I'm going to create the total juniors, which adds up to 145. I'm going to add up all the seniors, which totals to 132. I'm going to add up all the drivers, which totals to 139. I'm going to add up all of our taking the bus kids, that's 114. And I'm going to total all the walkers up to 24 to get an overall total of 277 students in the sample. Now, I want to find whether or not being a junior and driving to school are independent of each other. Logically speaking, they probably are dependent events because juniors are probably going to have some kind of a dependence on whether or not they can or can't drive to school. So let's see. So there are three ways we can do this. We can find the probability of being a junior and compare that to junior given drives. Label your variables. Or we can find the probability that a student drives and compare that to the probability of drives given junior. Or we can use the end probability rule and say, what's the probability of drives and junior? And compare that to the probability of junior times the probability of drives. All three of these are going to have different numbers within them, but they'll have the same conclusion, which would be that they are either independent or dependent events. So let's just do the first one. So the probability of being a junior, there are 145 juniors out of the 277 people in the survey. The probability of junior giving drives, we don't need the conditional probability rule because we have this nice two-way table. So we're only looking at the people that drive here, and there are 58 juniors out of the 139 drivers to school. Well, if we find those two numbers as decimals, we can compare these fractions a little bit easier. So the first one is a 0.523 probability. The second one is a 0.417 probability. Notice those are not the same. If they're not the same, they're not independent. So we can say being a junior and driving are not independent because the probability of being a junior is not the same as the probability of being a junior given the fact that we are driving to school. All right, last question for this video. I'll have another video out for the part 3 and 4 problems. So this is asking us, can this function be classified as an odd function? It doesn't say algebraically, so you could explain this graphically. I'm going to choose to do it algebraically. So if I find the value of f of negative x, I would plug in negative x for x, and then try and simplify. Well, when I cube a negative number, it stays negative, so we get this expression for f of negative x. Now, just to go over this, since we are reviewing here, if the function is even, f of x will be equal to f of negative x. If a function is odd, that means f of negative x will be equal to negative f of x, or the complete opposite of all of the signs. Neither of these things happen here, meaning this function is neither even nor is it odd. So the answer to this question is no. To justify your answer, you can just say because f of negative x does not equal negative f of x. Now, if we're talking about explaining this graphically, which is probably more likely how you would have done this, the graph of this, when you look at the graph of this, is going to be a cubic function that intersects the y-axis at 7. So it's going to look something like this. For a function to be odd, it has to have point symmetry, or 180 degrees of rotational symmetry around the origin, aka it's the same upside down. If I was to rotate this function 180 degrees, it's going to look something like this. That's not the same function. Actually, it would look more like this. That's not the same function. It's upside downish, but it's not intersecting the y-axis at the same spot. So what do you say? So you can say the answer is no, because f of x does not have rotational symmetry about the origin of 180 degrees. Now again, since we're reviewing, if this was asking about an even function, graphically speaking, this has line symmetry over the y-axis. Odd functions have point symmetry about the origin. Remember, point symmetry is just the fancy way of saying 180 degrees of rotational symmetry. Hopefully this video helped get you through those last few multiple choice questions and the part 2 questions. Please come back for part 3 and 4. We'll go through a 3x3 system and we'll talk a little bit more about what the part 4 questions look like. Best of luck studying.